Okay, dear students, welcome to the lab sessions. This will be your lab manual and we have already uploaded into the spectrums. So total we have 8 labs for the lab sessions, and let's start with the first lab sessions. For these labs we're going to using some IC integrated circuits, and this is the code for all those IC. So all this IC is basically the logic gate IC. Inside those IC we consist all those logic gates. And before we start, maybe we have to look into the general background knowledge. You need to know about that. When you go through these labs, you may see some schematic circuits. So in the schematic circuits, if you see the VCC or 5 volt, 5V or V plus, these all are referred to the positive side of your power supply. Then if you see a GND or all these symbols, this is referred to those the zero ground, the negative side of your power supplies. Let's say you have a battery, right? This is your positive side and this is your negative side. So in our circuitry, most of the time we're using the 5 volt and some is 3.3 volt. It depends on the design of the IC. So in the labs here, we are going to use those 5 volt supply. So this is the positive side of your 5 volt supply, and this is the negative side of your 5 volt supply. So this is the anode and a cathode. This is considered as an anode. This is considered as a cathode of your battery supply. Okay. Then and in our labs, we are going to use those logic gates, and as we know, logics there's only have 2 types of values, which is 1 and 0. Okay, so if you get a logic 1 in real system, it is basically a voltage levels. So in how are they going to determine whether is a 1 or 0? If it's a 1 means they are at a voltage level of 5 volt, and if it's 0 means they are at a voltage level 0 volt or ground. Okay, and anything connected to the negative side of your power supply, negative side, so this is a negative, okay, is considered as a 0 volt, and it is considered, if you detected this voltage level, they will consider as a logic 0. Anything connected to the positive side of your power supply, they will get a 5 volt, and in the logics they will consider as a logic 1. Okay, then in our labs we are going to use the breadboard to build our circuitry. So to be familiar with the breadboard, you need to know that there's a horizontal dot, this one, okay, and also the vertical line here. Okay, basically they are all in 5 holes at one line. Okay, there's 5 dot, if you can see in the pictures. All of this is hole where you can put in the leg of, or the pin of your components. Okay, and in this whole 5 dots, they are basically short circuited or is connected together. If you plug the pin into here, which means the whole line is connected to your the component. So for example, we look at this resistor. If you put the resistor leg in one of the pin here, which means this whole thing is connected to here, to the end here. Okay, then you connected another LED at this hole, which means you are connected the resistor here. Then this is your LED. Okay, then your LED connected to this line. So this whole line is connected together. So then if you connect the negative side at this line, that means LED negative side is at here, and then the positive side is at the another side of your resistor, if you look into this figure. So it's the vertical one, the 5 dots, they are connected together. The horizontal one, the whole row are connected together. And in some breadboard, you will see there's a break in between. Okay, there's empty line in between, right? So which means this is a they are not connected at this line here. So this row and this row are not connected to each others. Okay, so this is how you look at the breadboard. Then if you are given an IC, and an IC normally they have a few leg or few pins. So let's say I have a 5 pin IC, yeah. So this is your IC, there's 5 pins. I need to put this IC across the center of your IC across the center. So this is the way you put your IC. You put IC at the center, then this means there's a break in between, right? This 5 line is connected to each other, this 5 line is connected to each other, but this one and this one are not connected to each other. So by putting this way, we are able to separate 2 legs from each others. If we connect our IC at the same side, then this leg and this leg are connected to the same row, which means they are short-circuited. You are connected this pin to this pin directly. So this is must be avoided. So remember, whenever you put an IC, you must put at the center to separate the 2 sides of the leg so that they won't connected to each others. So this is the some basic principles of using the breadboard and how you connected all those IC. Please remember, the 5 dots here are connected to each other, then the whole row here are connected to each other, and in between this is a break. So this line and this line are basically not connected to each other. And the same goes to here. This line and this line are not connected to each other, even though they are the same line. Okay, in between there's a break. There's also a break in between here. Okay, so this is the basic concept of the breadboard. Then if we go further down, this is all the logic gate you have learned, right? This is the logic gate we have learned, and in this lab we are going to use some IC which is consists of all those logic gate, and all the ICs will have a 14 pins, 14 legs. Okay, 14 pins IC. And if you look into the picture, this is how the IC exists inside those integrated circuit, the IC. So the first pin here is the input. Second pin here is also the input. Okay, they are connected to the input of the logic gates. Then the third one is connected to the output of your logic gates. And in one IC, they will have 4 logic gates. Okay, and for your IC to be works, you must give them the power supply. So the pin 14 is for you to connect it to the positive side of your power supply, right? The VCC means the positive side. Then pin 7 is to connect to the negative side of your power supply, the ground. So remember, you must connect this positive side and negative side so that the IC will have power to works. Okay, then we will give input to the 2 inputs and get some data from the output. So this is the 5 IC we're going to use in this first lab. The 74LS00, the 74LS04, 08, 86, and 32. So by using this 5 IC, we're going to test the input and the output of the IC by using the LED. Okay, so this is the circuit how we design. And if we have a logic gate, then it should you should give an input either 1 or 0. Let's say this is an AND gate. You want to test it whether it's an AND gate or not. Then it should give you a 0 output. If it's an AND gate here, if you give 1 1, it should give you a 1, right? So how are we going to know they are going to give us a 0 or 1 at the output? So what you need to do is by using the LED to tell you whether it's a 1 or 0. So in the hardware circuitry, if it's a 1 means they are giving you a 5 volt. If it's a 0 means they are giving you a 0 volt, which means there's no voltage level there, so they won't give any power. So by doing so, we can connect the LED at the output side of the logic gates. Then the positive side connect to the resistor, then go to the LED, positive side of the LED, then the negative side LED go to ground. Then we complete the whole circuitry. So if let's say it's a 1, then I have a 5 volt here, which is a positive here. Then the other side is a negative here, so the LED lights on. We completed the circuit of this LED. So if it's a 0 volt here, so means this is a negative. This side also is a negative because the ground is equal to 0 volt also. So means there's no voltage difference. Both sides also 0 volt, so they will not have a current flow. So the LED will not lights on. So by using this method, we can know that whether the output is 1 or 0. Okay. Then for the input, if we want to supply a 1, then we need to connect it to the positive of the power supply. If you want to get a 0, then we just connect it to the ground of the power supply. So if you look into this, if you go back to the previous one, if you look into the logic of the IC, you can see this, the pin 14 is a VCC, so we need to connect VCC to the positive of a power supply. Then pin 7 is the ground. You need to connect it to the negative or the 0 volt of your power supply. Then there's a 1A, 1B and 1Y here, right? So this is equals to one logic gate. A and B is the input and Y is the output. Then the second logic gate is 2A, 2B and 2Y. So A and B is always represent the input and Y is represent the output. This is the same as the previous slide, right? So this is the 1A, 1B and 1Y, right? Then this is a 2B and this is 2A and it is 2Y, right? This is how they design the logic gate inside your IC. So by referring to these diagrams, then you can know what should I connect to. So at the end, if I want to using 1A, 1B and 1Y to test this IC, then my 1Y should connect to a resistor, then go to a LED, the positive LED, negative side LED, then I go to ground. Okay, so this side is same as the ground connection here. Both of these will connect to the ground. Then the 1A, 1B, I'm either connecting to VCC or I connect it to the ground. It depends on what kind of input values I want to give. If you want to give 1, then I connect to VCC. If you want to give 0, I connect it to ground. So this is how you do the testing of the IC to see whether the output is matched with the logic gate inside. And if you look into the LED, they should have a positive leg and a negative leg. So the positive side is always a longer one. Okay. This is one of the characteristic. You can differentiate whether which one is positive, which one is negative. Then the shorter leg is always a negative. Another method is if you look into the body of the LED, there's a flat side. So the flat side is basically represent the negative side of your LED, which is the cathode. So this is a two most simple way to differentiate the positive and negative. Okay, positive is a longer leg and negative is a shorter leg. Then the negative side also can differentiate by using the flat side at the body of your LED. Right, you can see there's a flat spot at the LED. Another method is by looking at the shape of the semiconductor inside the LED, but it's quite difficult. So the most common way they differentiate is by using the leg and also the flat side. And then this figure is the connection examples. So if you look at it, the red color one is represent for the positive, which means I connect the positive voltage into this line. So this whole line is a positive, right? Then I connect the negative, which is the ground. So this whole line is equal to negative of my power supply. So my IC need the power. So that's why you can see they connect this point to ground. So if you remember, the whole line is connected together. So which means I put this pin here. So this pin is connected to ground. Okay. Then I need the power supply, which is positive. So then this pin is connected to here, then it's same as this row, then this wire is connecting it to the positive, which is the power supply plus 5 volt. So I completed the power supply to this IC with these two wires. Then the next one is to testing the input. So they are using these two, which the 3A 3B. So this is the two input. They connected to, both connected to positive, so means they are giving the input 1 1 to this IC now. So the output side, it connect it to here, then they use the wire to pull it to here, then the wire come to here, go to the resistor. So the wire come to here, go to the resistor, then the other side of resistor go to the positive of the LED, then the negative side of LED come to here, go to ground. So this completed the whole circuit of your LED. So this is the thing you're going to do in your lab 1. There's some assignment you need to do. So the first thing, you need to fill up the tables by going through all the IC. Okay, by giving all the input values, then you fill up what are the output values you get. If the LED is lights on, then you should get a 1. If the LED is switch off, didn't light on, then it's 0, the output. Okay, this is how you determine the output values. Then to do these examples, we need to use a simulation software which is available online, which is in a tinkercad.com.